This is taken from the February-March paper, 2019 Computer Science iGCSE. It's question 5, and we've got a logic statement. I'm just going to read this to you. Consider the following logic statement. And it's a really long one, but it's basically broken down into 2 parts. X equals 1 if A is 1, NAND C is 1, nor A is not 1. So that's the first collection of numbers, and letters. Or B is 1 and C is not 1. So that's fairly straightforward. Yeah, or B is 1 and C is not 1. And then we've got here, draw a logic circuit that represents the given logic statement. Your logic gate, or rather your logic gates, must have a maximum of 2 inputs. Do not simplify the logic statement. Okay, well, let's try and break this down a little bit. What I want to do in this box, in order to get the 6 marks, basically what it's saying is, draw a diagram with 6 different logic gates. Okay, if you draw the 6 logic gates, you should be getting, you identify them all and you put them in, and if you put them in the correct order with the correct lines, of course, you're going to get 6 marks. But if you just draw those 6 logic gate symbols and you put them in somewhere, you'll be getting marks. You'll get marks for that. Okay, now with this, I'm going to work backwards. Okay, I need to identify the statements, the logic statements. Hopefully you can still read this. So I have, this is the important one, the OR gate. Okay, and that's going to be the first gate I draw. Yeah, but then we've got an AND gate, we've got a NOT gate, we've got another NOT gate, we've got a NOR gate, we've got a NAND gate. 1, 2, 3, 4, 5, 6 different gates are on there. Now, so you can see it a bit better, I'm not going to draw on this little shape here, but this is a 6-mark question. 6 marks, 6 gates. Hang on, things are starting to add up. So, I'm going to use this piece of paper here, and I'm going to put the X at one corner, and then I'm going to put my A. Can you see that? Yeah? My B and my C on this side. Okay? Okay. Now, in between, the one where I've coloured in black is the OR gate, the one that's not in any brackets. So basically, X is on if this is true, or if this is true. Okay, so the OR is going to go here at this end. So I'm going to put an OR gate in like this. And that's sort of what an OR gate looks like. Okay. Now I'm going to go back to this. Yeah. And again, I did say that the easy bit is the one after the OR gate. So B is 1 and C is not 1. So how am I going to do that? Well, I've got an AND gate. Yeah. So I'm dealing with B and C. So all I can do is I can put an AND gate. I'll put it down here. Like so, a bit of a long AND gate. I'm going to write in AND, yeah, and that one's an OR gate. So I've got my first 2 gates. That AND is going to go up to the OR gate. Now, yeah, it says B is 1. So B can come all the way down to the AND gate, okay? But C, it says C is not 1, yeah? C is not 1. So, from C, I'm going to put in here a NOT gate. Okay, that's going to go up there, and that's going to go there. Okay, so B is on, C is not on, and that's going into the OR gate. So that's basically covered Can you see this? That's basically covered that first bit. Yep. Now, this is the tricky bit. But I'm going to deal, again, working backwards. Nor A is not 1. Yeah? Nor A is not 1. So, up here, going into the OR gate, I'm going to put, sorry I'm left-handed so people can't see this, I'm going to put a NOR gate. Remember, all the gates we draw, if the NOR and NAND have got this little circle here, so that gate there is going to be my NOR gate. Yeah? NOR gate. But what's happening with the NOR gate? Well, it says here, A is not 1, going into that NOR gate. And then here, A is 1, NAND C is 1, going into that NOR gate. Okay, so I'm going to stick with the first bit. Sorry, I probably didn't see that bit. So yeah, so going into that NOR gate, we've got not A. A is not on. A is not 1 going into the NOR gate. Going into the other NOR gate, we've got A is 1, NAND C is 1. Okay, so I'm going to put this in first. I'm going to put this not A. So exactly the same as I did with C. Sorry, try and move that down. So I'm going to put, just trying to repeat myself. I'm going to put this not A, not what A is not 1 into this into the NOR gate. Yeah, very much like I did not C. C is not 1 into the AND gate. So it's basically a mirror image of the bottom. So I'm going to put a NOT gate up here, like so, and that's going to go into my NOR gate, and that's going from A. Yeah, so I've got that. But I've got this first bracket now. A is 1, NAND C is 1, and that's going into the NOR gate. All right, okay. So if I draw down here a NAND gate, which is basically an AND gate, like so, with a circle on it, and let me just label these so you can see them. NAND, yeah, and these are NOTs, or an inverter, yeah, or inverters. So I've got that, that, and that. Now, this doesn't say anything about a not NAND, it just says NAND. So A is 1 and C is 1 going into the NAND gate. So from A, I can come down here, stick it in there, and from C, I'm going to do that. I'm going to build a little bridge over B, and I'm going to put that in there. Okay, this coming up is going into my NOR gate. So that is basically the diagram. Yeah, so we've got X is 1 down here. If either of these two things, this one here or this one here, is on. Okay, so if that's 0 or that's 1, or if they're both 1, or if that's 0 or if that's 1 and that's 0, then this X will be on. Okay, so because we know how an OR gate works, either of them have got to be turned on, or both have got to be turned on. So going back through, nice and easy. The first bit, B is 1 coming into the AND gate, C is not 1 coming into the AND gate, and that goes to there, nice and easy. And then this next bit, yeah, we've got the NOR gate, yeah, is A is not 1 going into the NOR gate, and then A is 1, yeah, coming in down here, and C is on going into the NAND gate, and yeah, they're both going into the NOR gate. So that's it. That is the diagram. That will get you 6 marks in terms of this question. And that's taken me about 9 minutes to explain. So it's quite a tough question. You've got to know your gates, okay? But, as I say, I've got 6 gates on my diagram. I've got 6 statements here. If you can tally those up, yeah, if you can draw a diagram with those 6 gates on, an examiner's going to look at it and think, yes, they know what they're talking about. The next step is to make sure that the one out of the brackets is the one next to the X, or whatever this output value is here, yeah? But if you dot these around in some kind of order that makes sense, yeah? Because that is, to me, is the right answer. You might find another way of doing it. What it does say is, I believe, draw a logic circuit that represents the given logic statement. Your logic gates must have a maximum of 2 inputs. Well, of course, it's got A, B, and C, yeah? Do not simplify the logic statement. So we're not looking at simplifying this. We're not looking at changing anything into an XOR gate or messing about with this. You count the number of gates, 1, 2, 3, 4, 5, 6, and try and put them into this space. Yeah, and you'll do well. That is my advice to you with this. It's not as difficult as you might think. Okay, good. Now in terms of this one, yeah, we've got these things going in here, A, B, and C. If they're all set to 0, what will X be? If A is off, B is off, and C, well, we've got to work those through. We've got to put them through. Now, I know students work in very, very different ways, and you can put in pencil 1, 0, and then put them on here, or you can use this space here to work it out. I've used the space. I'm not going to go into too much detail, but I've basically I've tried to figure out what the value will be there, and what the value will be there at that point and at this point. Okay, so what will the values be there before it goes into the X? Because X basically means, yeah, whatever value is here and whatever value is here, if either of them or both of them are turned on, then X is going to be turned on. X is going to have a value of 1. So looking at this, as you can see here, if they're all 0, then obviously the D value is 0, the E value is 0, and then we're going to get a 0 there. It's only when coming through here, it's only when we've got a value of 1 or 0 here, which we have in the case of this. But you can break it down further. We could break it down and put some values in here. We could have D, E, F, G, H, and then X. But that's how I want you to be looking at it. So I'm going to leave that on screen for you to have a look at. Yeah, and wherever we've got a 1 or a 0, we must have a sort of 2 1s or a 1 and a 0. We must have a, because that is an OR gate. Okay? So that's it. So please, and I know people don't like doing this, please do use your working out. You don't have to do it this way in terms of that. You can put little numbers in pencil maybe on your diagram and ask for as much scrap paper as you need in the exam. But remember, you're going to hand that scrap paper back in. So that, my dears, that is answering that question there. Okay? And I've completed the truth table as I've just said. Okay? So that is February, March 2019, and that is question 5, all about logic. That's probably one of the hardest questions. Unless you're really au fait with logic, that's probably one of the hardest questions on a paper one. So hopefully have a practice. We'll get some more questions, get some more past papers, have a practice with that. Yeah, and you should be able to pick up 10 marks. Because remember, paper 1 is only out of, I believe, 75 marks. So you get 10, you're over 10% there with just that one question. Yeah? Okay. Right, that is it for now. Thank you very much indeed. I'll see you next time. Bye for now.